Optimal health for high performers. This is the Health Upgrade Podcast with Dr. Nawaz Habib.
Hello, everybody. Welcome back to the Health Upgrade Podcast. This is Dr. Habib. I am here with my co-host, JP. How are you, sir?
Doing really well, thanks.
Wonderful. And we are honored and excited about today's conversation with my great friend, Dr. Deanna Minich. This episode of the Health Upgrade Podcast is brought to you by Truvaga. Have you been looking for a simple way to feel calmer, think clearer, and sleep better? Imagine achieving this with just 2 minutes a day. I'm excited to introduce you to Truvaga, a handheld device that supports your nervous system through gentle vagus nerve stimulation. As a doctor specializing in functional health and wellness, I've seen firsthand how Truvaga has accelerated healing in my clients. I've used this device to help people with a range of issues, from sleep disturbances and heart palpitations to digestive dysfunction, nervous system imbalances, and mental wellness concerns. The results have honestly been remarkable. Truvaga is designed to catalyze and accelerate the shift in your body from fight or flight to rest, digest, and recover mode, helping you manage stress, maintain mental clarity, and unwind more easily. It's not just theory. I've witnessed its positive impact on real people facing real health challenges. The best part? Truvaga fits seamlessly into your routine. No need to carve out hours for wellness. Just 2 minutes a day can make a difference. It's a small investment of time for potentially significant benefits in how you feel and function each day. If you're curious to experience Truvaga for yourself, visit truvaga.com/upgrade. You can save $30 on your device by using the code UPGRADE30 at checkout. Remember, that's truvaga.com, truvaga.com/upgrade. It might just be the first step towards a calmer, clearer you, just as it has been for many of my clients. How are you?
I'm doing well. I'm so looking forward to this with both of you.
This is going to be an awesome conversation, something that we've alluded to. You and I have had a couple conversations about this particular topic at a few conferences, and we've crossed paths so many times, and we're finally honored to have you here with us to have this conversation properly. So the topic that we're going to be discussing is melatonin. And melatonin, as you mentioned earlier, has been pigeonholed into this idea of just simply being about sleep. And I think today we're going to try to bust that myth a little bit, go beyond the idea of just sleep. We're going to talk about the science of melatonin, what its roles are within the body, the mitochondrial role, something that we've mentioned in the past. And we want to dig into a little bit on the spiritual side and not necessarily go off into woo-woo land completely, but certainly allow for there to be something a little bit greater than just the basics being presented in today's conversation. So we're really excited to dig into that topic. But before we do, I would love to learn a little bit about you and kind of your journey into melatonin and kind of your entire healthcare realm and how you became so involved in the holistic and functional medicine space.
Oh, goodness. Long story short, I met Dr. Jeffrey Bland, the father of functional medicine, back in 2002. Started working with him in 2003. And I would say that was my entree into functional medicine. So I had been not just working with him, but then started to work with the Institute for Functional Medicine. I became one of their educators. So I've kind of grown up in functional medicine. It's been my professional playground. And I've also been in clinical practice. I've done clinical trial work. And as far as it takes me to melatonin, because my training is actually in medical science and human nutrition, and I would say I didn't really study melatonin all that much. What turned me on to melatonin is, I would say, the pandemic, when we got into looking at different protocols for immune health. And I actually wrote a paper together with Dr. Patrick Hanaway, who is our colleague in functional medicine. And in putting that together, started to come across a lot of information on melatonin in these protocols. And I was like, what is this? Because, we would talk about zinc, the steady eddies of immunity, vitamin C, zinc, and the whole host of different things. And then I started to see melatonin creep in, and that led to my curiosity about it. Soon after that, I would say in 2022, I came into working with a company called Symphony Natural Health, which coincidentally has a plant melatonin. And of course, like everything I do for the most part is connected into plants. So once I could see the science of melatonin as it connected into plants to understand how it was used in plants, and plants don't have a pineal gland, they're not sleeping. So what is the melatonin doing in plants? So, that just led me down a path of curiosity. And then we published a paper in September 2022. It seems like so long ago now, but it was entitled, "Is Melatonin the Next Vitamin D?" Because there were a lot of similarities as I was studying immune health before I came to Symphony, looking at vitamin D. And vitamin D was getting a lot of play with, being out in the sun and making sure that you've got your full spectrum light exposure. But then there wasn't really the reciprocal talk on the side of melatonin and darkness deficiency, that we don't only have a sunlight deficiency, we have a deficiency of darkness. And in fact, it's not just a deficiency of darkness. We have an excess of artificial light at night, which has been referred to as ALAN. So it's disturbing ecosystems. I even call it the most societally accepted endocrine disruptor, because we think light at night is a good thing, right? We know plastics are bad. We know heavy metals are bad, but we don't know that artificial light at night is bad. We mostly think, oh, well, it disrupts our sleep, but we don't look at the further implications of that and what that actually means. So that's more or less how I got into it.
I think this is such an important topic, and this idea of darkness deficiency really being something that we have taken for granted completely, right? It's light is for the daytime. And yes, we've built out light so that we can travel at night, so we can do things. And then now we have all of these cell phones and computers so we can work at night or work anytime. You're absolutely right. We've certainly created this experience of not having those moments of darkness available to us. And melatonin relies on darkness to be activated within our bodies. And I wonder, on your studies that you did with plants, or that the company previously had done with plants, and that curiosity of why melatonin is present in an organism that doesn't have a sleep pattern the same that we do. What did you kind of learn there? Was it darkness that played a role there? I'd love to dig in there.
Yeah, there is a circadian pattern in plants. So there is something there. But when we look at melatonin in the variety of different plants, and even if you look at some of the literature in agriculture studies, what you see is that melatonin is even sprayed on plants as a growth factor. So it's seen as an endogenous growth factor that can stimulate the release and the production of certain compounds, like even greater amounts of phytochemicals. So when we think of, I think in functional medicine, we talk a lot about metabolic detoxification. I talk a lot about eating the rainbow of colors in plants, all these pigments. Well, where are they coming from? Those are environmental cues that the plant is responding in some way. And melatonin serves a purpose with respect to the photosynthetic process and helping to enable the production of certain phytochemicals, especially things like glucosinolates, which again are a key class of compounds in plants that are protective, that serve a variety of different functions. So I'm no botanist and I'm no, I would say, plant scientist, but from what I have seen as it relates to plants, it's just really intriguing. Even when I talked with Dr. Russell Reiter, who I would call the father of melatonin. If Jeff Bland is the father of functional medicine, Russell Reiter is the father of melatonin. And I had the great privilege of flying to Texas, having breakfast with him, interviewing him in person on everything I wanted to know about melatonin, like just to tap into his 87-year-old brain on all things melatonin. And he even made the comment about, he was aware obviously of this, the relationship with plants. And he even mentioned about putting a little bit of melatonin into like flowers. After you've cut them, you put them in the water and then put a bit of melatonin to keep them longer. It's like, oh my gosh, like all of these dots that we're connecting by way of that conversation, right? And if you start to put into play the principles, just like we do when we translate science into clinical application, it's like, oh, wow, it makes sense. And if you look at his book, he has a consumer book which even though it was published in 1995, a lot of what he wrote about in 2025 holds true. And there was a study that he reported on. It was an animal study in which melatonin was put into the drinking water of certain animals and not of other animals. And for the animals that had the melatonin in the drinking water, they aged 20% less than the animals that did not have melatonin in the drinking water. Now, that doesn't mean that I think we should have melatonin in our drinking water and be sipping it throughout the day, but it does really get into the pleiotropic effects of melatonin, that they are well beyond sleep. In fact, sleep is just a byproduct of what it's doing as a result of circadian entrainment.
So let's dig into that, because I think, even at this point in our podcast, there's still a lot of listeners out there still saying melatonin is that sleep supplement. And you mentioned the pineal gland and the fact that, yes, in human beings, it's manufactured there and released from the pineal gland to sort of regulate sleep. But those are certainly not the only cells in the body that make melatonin. And plants, as we pointed out, they don't have a normal sleep cycle. They do have lots of cycles that may or may not be regulated by melatonin, but they're not manufactured in a pineal gland. The melatonin is made in many cells. In our body, it's made in nearly all cells. So just diving into the synthetic process, where's it come from? Where are the key sources in the body that are making it and releasing it? And then is it not true that almost all cells in the body are manufacturing it for internal use within the cells?
Yes, to everything you said. So let's unpack that. Normally when I'm presenting on melatonin, that's like one of my first entry points into the conversation of like, what is melatonin? Where is it found? Where is it in the human body? So when we think of the human body, you're right, pretty much all different compartments of the body, different cell types, will either take up melatonin or manufacture melatonin. Melatonin is created from tryptophan. Tryptophan is an essential aromatic amino acid. We get it from the diet. So tryptophan converts through a series of different enzymatic reactions, about 5 of them, to give us endogenous melatonin.
And it goes through a really important step in between tryptophan and melatonin, which is serotonin.
That's right. That's
And
right.
And we know how important serotonin is. I mean, serotonin is mood, it's pain, it's gut motility. It's really regulating all the different cycles of motion in the body. We've talked about that in many podcasts.
Absolutely. I'm glad that you shine a light on that, because it'll come into our conversation as we talk about consciousness, talking about the two, I would say the brother and the sister, serotonin and melatonin, and how they play a role there. And that's a really good point, because if we're modifying serotonin in any way through an SSRI, or we have differences in mood state, or if we have a flux in our neurotransmitters, it could impact melatonin. Inflammation in the brain can also impact melatonin. But let's get into the different body compartments where it's found, just so everybody gets a sense. It's basically all the body compartments do contain melatonin. It is not found in hair or in nails. In other words, like dead tissue, like tissue that's not living and doesn't have active mitochondria. Wherever you have mitochondria, you're going to have melatonin. So when I think of the heavy hitters in terms of the body, I think of course, the brain. And we're going to get into lymphatic fluid flux, which I gave a whole presentation on, just 30 minutes on lymphatic fluid flux at the last A4M conference. It's really fascinating, and melatonin seems to play a role in that, but we'll get into that in a little bit. But the eye, of course, the skin is a huge conductor of all kinds of signals, and we can make melatonin through the skin, the liver, the kidney, the thyroid, the thymus. Even in the immune system, there are a variety of different cell types that are all connected into melatonin. And when I think about it, here's how, for people listening so that they don't feel overwhelmed with all of this, think of melatonin in 2 camps. One is created by the pineal gland in response to darkness and is truly endocrine, because the eyes perceive darkness, that signal is sent through special receptors in the eye to the suprachiasmatic nucleus, this cluster of 10 to 20,000 neurons, which then signals to the pineal gland, hey, you need to make and secrete that melatonin. That goes out to the entire systemic clock gene network. Okay, so that's a very classic, I would say, darkness specific circadian rhythm regulation aspect of melatonin. Because during the day, our blood levels of melatonin are negligible. So it's really between 2 and 4 a.m. that we get this spike, and that's from the pineal gland. Now, in other parts of the body, there is non-pineal melatonin, what you were referring to, JP. So we have the cellular production of melatonin. So that, again, can happen in the skin. It can happen in the gut. In fact, the gut is one of the primary repositories of melatonin. We make something on the order of 100 to 400 times the amount of melatonin from the pineal gland in the gut. And that's not in response to darkness. That's a little bit different. And what we see is that it may be playing a role in modulation of the gut microbiome. It may have a role in motility, because we see it at every part of the gastrointestinal tract. It's in the lumen, it's in the mucosa, it's in the smooth muscle layer. So I think that it still remains a little bit of a scientific enigma in terms of what is it exactly doing there. But we see a lot of different neurotransmitters there too, right? Now, the difference between pineal melatonin and non-pineal melatonin is that the non-pineal melatonin would seem to work in a more autocrine, paracrine function, not a true endocrine, which means that it's being produced locally and either used by that cell that it's being produced by, or it's being used in neighboring cells or in close proximity, but not a true endocrine where it's like produced from a gland and then, changing function somewhere else remotely. So that's how I would think about it.
Do you know if melatonin production is proportional to the number, or not necessarily the number of mitochondria, although that's usually typically aligned with the amount of metabolic activity that's going on in that cell type, versus muscle versus fat cell as an example? The reason why I ask is because melatonin is such a potent antioxidant, and it's used by your mitochondria as a potent antioxidant to protect against free radical damage and reactive oxygen species damage. And so, that the production locally of melatonin, one of the purposes, not the only, but one of the purposes is within the mitochondria, because one of only 3 antioxidants, people talk about vitamin C and vitamin E, and those are great as antioxidants for the cell, but they don't get into the mitochondria. There's only superoxide dismutase, melatonin, and glutathione that get into the mitochondria directly and can actually, quench those free radicals and reactive oxygen species locally in the mitochondria. In fact, correct me if I'm wrong, and I'm remembering this and I might be misremembering it, but I believe that melatonin and the enzymes for making melatonin are actually present inside the mitochondria, so that mitochondria can actually synthesize melatonin themselves if necessary.
That's correct. And everything you said is true, that melatonin is very unique to the mitochondria. And part of the reason for that is because of its amphiphilic nature. And what that means is that melatonin has a very unique chemical structure in that it can flex to being water soluble, which is why it's found in the watery compartments of the body, like the blood and the urine. And it can also be fat soluble. So the mitochondria, which has it has this bilayer lipid membrane, right? So it's really important to have lipid signalers within the mitochondria. The melatonin that is in the cell can therefore be taken up by a mitochondrion, and the mitochondrion itself can actually make melatonin. In fact, if you look a bit deeper into evolutionary biology, it is thought that we evolved in part with the capacity to quench these free radicals in order to prevent us from going rancid. And the mitochondrion was part of enabling us to use oxygen efficiently, right? And to engage in aerobic respiration. And in order to do that without going crazy and producing all these free radicals that are just going to decay us, there needed to be some endogenous protection built in. And that's why, in part, I call melatonin the mother molecule, because it's so closely connected to the mitochondria, which 90% of the genetic material is coming from the mother. So I often think, when we're looking at people's endogenous cellular protection, we need to look to the maternal line. What was her energy production like? Was she very robust and resilient? But yeah, I think many people don't realize that melatonin is amphiphilic. So new word for the day for some people, but basically it means it can go everywhere. It's not limited, like vitamin C stays in water. Vitamin E stays in fat. Carotenoids like beta carotene go into fat. So certain antioxidants are limited by their chemical nature, and melatonin is not limited. In fact, if you look at Dr. Dunshan Tan's work, and Dr. Tan studied under Dr. Russell Ryder, and I even met him. He's another brilliant mind in this whole area. So I'm standing on the shoulders of giants when I talk about all this. But his work would show that one molecule of melatonin and its metabolites can scavenge up to 10 free radicals. Whereas if you look at something like vitamin C, it can scavenge up to like 1 to 2 free radicals in certain kinds.
I've heard it's as high as 13 separate free radical or free active oxygen species can be quenched by melatonin. So yeah,
I'd
least
love
10.
to see that, because when you look at Dr. Tan's paper, it's definitely like 1 to 10. So, and even its metabolites are antioxidant in nature. And many times when an antioxidant is working in the way of quenching and getting within the free radical cascade, it can actually become a pro-oxidant, and that doesn't happen with melatonin. It just keeps on giving.
That's a fantastic topic that I like to talk about with respect to inflammation and melatonin, because that tryptophan origin, that amino acid that's the origin of making serotonin and then melatonin, there's an alternative pathway, which is the kynurenine pathway. And we've talked about this in the context of depression because it's found in high concentrations in people with depression. But kynurenine and kynureninic acid and all the way down to quinolinic acid, the entire metabolic pathway of tryptophan, which is the alternative to serotonin and melatonin, makes free radical promoters. All of those are free radical promoters as opposed to quenching the free radicals with melatonin. And so when you're in an inflamed state, you are creating more free radicals, you're promoting them, versus quenching them. And you say, well, why would the body ever want to be in a state where it's promoting free radicals? Because it's going to cause damage. And the reason is because if you're infected with a microbe or a virus or some other pathogen, the cell wants to become more inhospitable to that pathogen. And it does that by shifting the metabolic pathway away from making serotonin and melatonin and in the direction of making all of these free radical promoters and it's willing to suffer the damage and the consequences temporarily. But that's why chronic inflammation is so bad. It's so dangerous. And that's why you see this acceleration of aging associated with inflammaging, whereas melatonin is going to slow down the aging process, which is something you brought up earlier. So it ties back into inflammation in a way that I find fascinating.
Yeah, and I'm so glad you bring up the kynurenine pathway, because it is an important feature to consider, especially for brain health. We know that 95% of tryptophan is going through kynurenine. And 5%, like just a fraction of tryptophan, is shunted over to serotonin, which then can go on to melatonin. And again, those 5 different enzymes responsible for melatonin conversion, they are nutrient requiring. So if we fall short on the nutrients required, and a few of them are methyltransferases. So if we have inefficiencies in our enzymatic pathways, either genetically or from a nutrient cofactor perspective, it really doesn't enable that endogenous production fully. And if we are stressed and we have inflammation, to what you're speaking to, now our need for nicotinamide adenine dinucleotide, otherwise known as NAD, right? There's a lot of talk about NAD. We need energy and we need to harness that. And in making that energy, that NAD, that B vitamin, it's almost like, the body can take it in a variety of ways. We can have kynurenic acid, which is more neuroprotective, but then quinolinic acid, as you spoke to, can be neurotoxic. So it's about, obviously the balance, which is why when people say like, well, why is my melatonin going down with age? Well, again, just inefficiencies, whether metabolic, more inflammation, and more issues, which it's almost like, you rob Peter to pay Paul, as the phrase goes, right? Like you have all these rate limiting steps. And so it's a tender balance. And that might be part of the contribution to aging.
One of the things that I learned recently, I was doing some research for a presentation on the vagus nerve in circadian biology, which was really interesting because it really tied together a lot of the melatonin as a sleep aid and obviously as a tool for engaging in that circadian rhythm. One of the pieces of literature that I read talked about melatonin having a sympatholytic effect, essentially being able to downregulate the sympathetic activation, enabling vagus nerve signaling to become more efficient at the cellular level. So the acetylcholine being able to then activate specific receptors with a greater degree of efficacy. The idea here that I've kind of been toying with now is if we have so much melatonin being produced in a paracrine sense or autocrine and paracrine sense in the gut, because that's where the majority of the tryptophan lies, that's where the majority of the serotonin is produced, and the conversion to melatonin will take place. But we also have about 70% of our immune cells by volume located in the lining of the gut. Does that not compute to say that there may directly be this correlation that we're trying to engage the immune cells when there is a good amount of melatonin being converted and being produced to downregulate immune system activation and not allow for us to get into these chronic inflammatory situations, not allowing leaky gut to take place, not allowing there to be this hyper sympathetic release or activation at certain areas? Could there not be a correlation between these two?
And a whole lot of vagal innervation as well.
Yeah, absolutely.
So it's the immune system, the gut's producing the melatonin and serotonin, and you get a lot of vagal innervation. So players are there.
Navaz, you connected a lot of dots there, and that makes really good sense. And if you think of melatonin from a nervous system perspective, what is it doing? It has a somnolent effect, right? We kind of get this, the sleepiness that can set in when we have melatonin. What is melatonin actually doing with sleep? It's opening the sleep gate. It doesn't necessarily keep it open, but it kind of gets that soporific, kind of like the sleepy, hypnotic. That's why on melatonin supplements, many times it will say on the package, don't take if you're operating machinery or driving, because it has that calming, sleepy kind of effect, right? So that all makes really good sense to me. And I'm glad that you brought out that fact of 60 to 70% of the immune system being housed in the gut. So no wonder you have such a huge reservoir of melatonin being made there.
So let me go back to a different question or a different point that you raised earlier, because you talked about eating the rainbow. And the colors, the bright colors that are in plants are often the result of polyphenols. And the importance of polyphenols in our diet can't be understated. And one of the roles that polyphenols have is as a mitochondrial uncoupler. And so, and just for everybody listening, mitochondrial uncoupling to me is the equivalent of sort of the cheat code for weight loss. Because what you do is the polyphenols take some of the energy that your mitochondria are making and immediately converts it into generating heat. So literally these polyphenols have the ability to raise your body temperature, and then you'll burn off excess energy without having to actually go exercise because you're just raising your body temperature. But the way it does that is it shunts the electron transport chain, allows it to sort of short circuit and generate heat. But that also is a way of reducing the risk of free radicals and reactive oxygen species production. So it's really helpful from that perspective also. What is the relationship between melatonin and these polyphenols that have this mitochondrial uncoupling effect? How do they interact with one another?
I give a whole talk on this actually, because I have this love of these blue-purple compounds in plants. They're not all blue-purple, but they tend to be found in blue-purple foods, sometimes red, sometimes brown, and even green. So what's really unique about polyphenols, if we just break the word apart, is you have this phenol group. So if you can imagine an aromatic structure like this benzene ring with a little hydroxyl group hanging off of it.
So basically, a hexagon of carbons connected with a small little dangly molecule hanging off the bottom of it, or a moiety hanging off the bottom of it.
Yes, and it's not just one of those rings. A polyphenol refers to multiple rings together. So if you look at the quantum physics that would relate to these aromatic rings, which are very unique. So not all structures in nature have them, but these polyphenols have high concentrations of them. They can carry the electrons very well. So they're kind of like sinkholes for a lot of these radicals that are being produced by the mitochondrion. And when we look in the brain, this might get us into this consciousness discussion, because what we see is that there are these microtubules in the brain, and lining those microtubules, we see are these aromatic ring structures. And it's been proposed that they oscillate, they resonate. And if you look at some of the other literature on polyphenols, they are now starting to be looked at as chronobiotic agents. So what does that mean? That means that they have some implication in setting the circadian rhythm, like melatonin, but different than melatonin. And the way that they would crop up would be with seasonal foods. So if you think of cherries, which would be rich in polyphenols of certain types, cherries would be more of early spring to early summer food, depending on where you live. Those polyphenols are priming the hypothalamic function in a certain way to regulate metabolism, especially of lipids. And there have been animal studies that show that when you feed cherries out of season, you're actually changing lipid gene metabolism. So like the metabolism of those genes. So when you talk about weight loss and through the mitochondrion and such, essentially these polyphenols are having some translation into modulating our metabolism at the genetic level. So if you're feeding foods out of season that have polyphenols, but other things too, by the way, not just polyphenols, but the polyphenols show up very strategically through nature at certain times of year. We don't always have these purplish foods. We get grapes many times in the autumn. We have cherries many times in the spring. And this is why eating seasonally is so important, because nature is giving us what we need in order to stay in rhythm, and not just stay in rhythm circadian wise, but metabolically speaking. So that's what I would say about that these two play really well together, just to have the melatonin and the polyphenols together. You know, it's nature working together in all of these structures, right? It's really beautiful.
No question. This is a thing that we've come back to a few times, is the cyclic nature of the human life, right? Like life happens in cycles. We have day and night cycle. We have seasonality that our body kind of follows. And when we live in harmony with that cyclic nature of how Mother Nature is providing for us, right? We're getting foods at certain times of the year based on seasonality, based on what nature is providing at certain times. We're engaging in this almost coherent pattern of living within the pattern of nature. And I think that's so unique to the linking the science and the spiritual, where we can kind of take that step back and say, yes, we can now understand because we have the scientific basis for this, and the idea of providing the right polyphenols at the right time of year help to engage certain things and shift your circadian biology so that you can be awake longer during the summer and be able to sleep longer during the winter. And you engage in more recovery patterns during the winter time when there's more dark hours and there's more light hours, so you can be more performative and more active in the summertime. There's this real rhythm or pattern that needs to be engaged in. And so providing these right polyphenols based on color, based on seasonality, actually aligns your inner rhythm and creates this pattern of calm, of flow, rather than constantly needing to go against the rhythm of life, I think.
This is the science behind why movements to buy local and buy from farmers in your region make sense. Because if you're in Maine or, in upstate New York, and you're buying your food shipped in and your fruits and vegetables shipped in from, the San Joaquin Valley in California, that's not giving you the nutrients. Well, first off, whatever nutrients are left in those foods by the time they get to you, and even from the depleted soil, but what nutrients are in them are not appropriate necessarily for you at the time of year if you're eating that with 8 feet of snow on your roof, when it's sunny and warm in the San Joaquin Valley. So you should eat locally, eat foods from farmers that are, obviously growing regeneratively, et cetera, but do those things also because of your circadian rhythms and the other rhythms that we're talking about in your body, because that's where you're going to get the right cues. You're not going to get the right cues by eating, foods out of Hawaii or South America at that time of year.
Yeah, as one of the physicians I used to work with, Dr. Jack Kornberg, when we would see patients together, I remember him telling this one patient, he said, "You're eating oranges in the winter, which is telling your body to store fat and act like it's summer." So, he was pretty emphatic about that. But what I would say is it's not to mean that you can't have an occasional orange in the winter. But when we get into our eating ruts, which so many people are, they're in what I call food ruts, right? They're eating the same thing day after day. They go to the store, they buy these big bags of one fruit, one variety, no dietary diversity, and they don't even think and connect with it. And I feel like that connection with nature, talking to the person in the produce section. And I love that we're talking about circadian rhythm. We're talking about seasonal rhythm. Let's not forget we also have lunar rhythm, the menstrual cycle, which plays big into women's nutrient status. We have hormonal rhythms. We look at men's health, andropause. We even have the month of birth, which I don't know if you're familiar with some of that work. I just made a post on Instagram about it yesterday, about how depending on the month that you were born, there is a subtle risk in either direction for certain diseases. And that would track back to preconception, in utero development, accessibility of nutrients. But that was very simply done through looking at a lot of different hospital records at a hospital in New York and looking at correlations between, it's such an easy thing to do, right? You just look at birth dates, you look at what did they die of, and then you start to make the links. And that's what they found was that certain diseases, whether respiratory, cardiovascular, that they had synced up in certain months. Not to say that that's not modifiable, but it's a season. It's a type of rhythm that we're connected to. And that's a more personalized one, right? Because not everybody was born in the same month.
Yeah, no. And, I always get accused of being, the science guy who, takes the fun out of things. But, I always look at things like the zodiac signs and the astrological predictions, et cetera, and said, honestly, there are tremendous differences that occur in gestation and early childhood that happen in very brief periods of time. And if you're going through one of those phases in January versus July, you're going to have a very different set of experiences, both chemically with respect to the foods that you're eating and the nutrients that are available, as well as the experiences. Are you in the house with short days, or are you playing outside in the grass on with long days? Those are very different effects. And so some of the personality features, are you a Sagittarius? Are you a Virgo? Are you Taurus? Those things actually have some scientific grounding, not because of the specific positions of the stars, but other than the star that's our sun. And that is affecting personality. It affects your risks for certain diseases and your behaviors. So yeah, the cycles of life go even into, whole generations.
I love that. I'm so glad that you mentioned that because, just like many things, something like astrology has just had a bad rap, right? It's kind of like, oh, it's so woo. But then if you look at the Vedas and you look at different ancient traditions, my husband is a TCM, traditional Chinese medicine practitioner. I mean, you look at the powers of observation, right? Like people born in December having a certain phenotype and way in the world, potentially. It was just done through powers of observation and then looking to see like maybe moon cycles. I mean, I know we're diverting a bit from melatonin, but, I just want to say something about lunar rhythm and melatonin because I don't bring this up on many podcasts, but there was a study that was done in a sleep lab. And what it showed, it was a smaller study, right? It wasn't like a huge, like thousands of people. It was in a sleep lab with a smaller amount of people. But basically, they tracked melatonin levels. And what they found was that melatonin dipped 4 days before and 4 days after a full moon. In other words, it was kind of like, you have your 28 days. Melatonin endogenously was produced the same like new moon and on the other end. And then when it was the full moon, it would come down. And you would say, well, that's because it's brighter at night. The moon is out and it's shining. But this was in a sleep lab. They controlled those factors. So what about our ancestral rhythm was leading up to, did we have to be more alert at night? So we had less melatonin that was made endogenously because sleep, we hear this all the time about people not sleeping well during a full moon or having disturbing dreams during a full moon or, and
behaving crazy.
Behaving crazy during a full moon. They don't have their melatonin during a full moon.
The whole concept of werewolves coming out at the full moon, right? Like that.
That's right.
There's something there.
That's right. So I think that this will segue us into a bit about like, what do we do about this, right? So we know that let's just look at our life cycle, just since we're kind of riffing on rhythms, let's look at our life cycle. So at the moment of birth, a child does not have much melatonin. He or she gets their melatonin from the mother. And that starts to increase rapidly within that first year. Then as a child, it's increasing exponentially. This is why sometimes babies have colic. It's kind of like they're not sleeping. They're out of their rhythm, right? They get their rhythm finally. Then they are really good with melatonin endogenously. In fact, as a child, you had the most amount of endogenous melatonin that you'll ever have in your life. So for all these kids on melatonin gummies, I'm not up for it because it's like, this is a sleep hygiene thing. This is not endogenous melatonin. If you look at the physiology, kids should have this huge amount of melatonin produced naturally. Not huge, but I mean, in the way of like physiologically appropriate, right? Yeah.
And they need to sleep more. Kids do not sleep anywhere near as much as they should.
That's right.
Kids up until age 11, 12 years old should be sleeping 11, 12 hours a day. Not 8 hours.
I totally agree. And in fact, I talked with a neuroscientist here at the University of Washington, and he was really bullish and was involved in this whole initiative with getting the Seattle school system in a different sleep pattern for children. They changed it by 1 hour, made all the difference in terms of sickness, attendance, performance, like just 1 hour. So we have to really look at sleep hygiene with kids. We're not doing them a service with the lights at night, devices, iPads, going to sporting events with artificial light, fluorescent light in these big event halls, or, taking them to the grocery store late at night with all those bright lights. We really need to get back to basics here. But then as we go through puberty, things start to change. We start to come down. I'm talking now pineal melatonin. So we start to come down. So by the time we hit middle age, which let's just say 35 to 40, we're at about a third of what we had when we were a child. When we make our way into our 50s, like me now, I'm mid-50s, I have a tenth of what I had as a child. And it just keeps going down, down, down. And you can kind of look at an overlay of this low endogenous melatonin increase in what? All kinds of risk for neurodegenerative conditions.
Cardiovascular.
I mean, it could be the whole host of things. Like, where do we even draw the line? Because again, it's everywhere. It's a cellular nutrient and antioxidant. I call it a circadian nutrient, actually. I made that up. But it is. It's something we're going to look at it in years to come, like the next vitamin D. We truly are, because now everybody's just on vitamin D. But it's not just vitamin D, right? And it's not just melatonin either. It's just that melatonin has been left out of the conversation.
Do you worry that, because I get this question sometimes about melatonin supplementation. And the question that I have is, the body has lots of ways of sort of feeding back information to itself. And if you're supplementing with melatonin taken orally, okay, assuming that it's getting into the gut and into the bloodstream, there's now a level of melatonin that exists. And if the body says, okay, that's all I need, is it going to shut down serotonin production? Because serotonin is the precursor for melatonin. And since you now have enough that you're supplementing, are you going to stop making as much serotonin? And are you going to end up making more of, down the kynurenine pathway down to quinolinic acid on all the free radical promoters, simply because you're overloading the melatonin, which is a downstream metabolite from tryptophan? And would it not be potentially a better strategy, instead of taking melatonin directly, to take tryptophan, to give your body more of the tryptophan?
There has been no scientific evidence that I have seen where scientists have set out, or even clinicians have set out prospectively to look at whether or not the body stops making melatonin when you take melatonin supplementation. There have been, I believe, at least 4 different clinical trials where they set out to look at that and have not found that. And I think it's because melatonin is not a true hormone. It's not working in the same negative biofeedback loop that something like testosterone would. Now, that said, it also depends on the dose of melatonin and what you're actually taking, right? Because I think what happens in our society is it's the shiny object syndrome, SOS. It's kind of like, if a little is good, let me just take large amounts. And whenever I'm on podcasts like this talking about melatonin, the person will tell me, oh, I take 300 milligrams of melatonin. And I'm thinking, or 100 milligrams, or I'm taking 20 milligrams. Now, if you're taking high amounts over time, we don't actually know the repercussions of that. Now, that has not been studied. Are you reducing the sensitivity of the receptor sites? Are you creating a higher need for melatonin? How are you changing the dynamics, right? Because nutrition and nutrients and antioxidants, it's all about relationship.
Well, there is some at least anecdote that you hear of people who use melatonin to help with their sleep, that withdrawing from melatonin, not taking it, leaves them with a difficulty getting to sleep that they didn't have before. So they take it to help them get to sleep, but then it's sort of like Unisom or one of these other things that are used to help people to get to sleep. Once you withdraw it, then the natural adenosine pressure, inflammatory cytokine pressure, melatonin pressure isn't there to drive them to sleep, and then they have a difficult night's sleep as a result. And it takes them a few days to sort of get back into the effects of being able to sleep without supplementation. So that would suggest to me that there is some sort of feedback mechanism involved. And I don't know if that's more just anecdote, and the plural of anecdote isn't evidence, but what's your take on that?
Sounds like there's more going on there than just melatonin. There are many root causes as it relates to sleep dysregulation. And I also think it's about the dose. What were they actually taking? Because, taking even 3 milligrams, 5 milligrams. And what I personally take, I'm not recommending this for anybody, but I take a physiologic level to patch the gap of what my body at 54 is no longer making, right? I'm not trying to, it's like HRT or MHT. I'm not taking supraphysiologic levels. I am taking biologically appropriate levels that would help with physiologic function that we would see to be safe. Like I take 0.3 milligrams. Whereas I was saying before, people taking like 100 milligrams or 20 milligrams, that's fine. Do what you want. But there isn't the science that makes me feel comfortable to take that long term for healthy aging. But looking at 0.3 milligrams, which I see that different opinion leader organizations can get behind, again, it's physiological. If you look at the curve, it is replenishing rather than overriding. And this is where I think people have the issue where they're taking high doses of melatonin, then they withdraw. Yeah, it may take them some time to shuffle because they are changing the receptor sites in terms of desaturation and then like needing to kind of overcome and get back into balance. But I also think it's about the type of melatonin people are taking. 99% of melatonin on the market is synthetically derived. In fact, just even recently, I had to go and look at a synthetic melatonin because somebody was telling me that they were taking it. And I looked at the specification of it. And up at the top, it said all of the things that were in it or that it was derived from. It's all like petrochemicals, right? And so like, even if you go and look at a lot of the patents of melatonin synthesis, you will see this, a lot of derivatives. So there have been articles talking about potential for contaminants in synthetic melatonin. So what are they actually reacting to? Is it the dose of melatonin, which is way too high for what they need? Because again, it's not supposed to be hitting you over the head to go to sleep. It should be gently sending that signal of darkness and the circadian tone to just gently wire you into sleep. You shouldn't have these side effects. So that's why I do use herbatonin, because it is plant melatonin. It's not an extract. It's actually like the cell matrix of plants. And I take it at the low dose of 0.3 milligrams. And it's funny because I have a number, as Navaj, you know, I'm very connected into the functional medicine, integrative medicine community. And, you know, I have a friend who is a naturopathic doctor. And when she heard me talking about this, she's like, I don't know. So then she texted me and she's like, oh my gosh, I started taking the lower dose. And she's like, I'm amazed that I'm just a happier person in the morning. She's like, my whole family. She's like, I didn't believe you, because she was taking a higher dose and she didn't have good results with that. She went off of it. So anyway, I think it's about the dose makes the poison. The dose makes what is relevant for the person. Okay, so here's a little nuance. We metabolize melatonin through the same cytochrome enzyme that we metabolize caffeine. So let's just say somebody is highly caffeinated through the day. That's going to change their nightly melatonin levels and can also change how we metabolize it. So depending on how you respond to caffeine, like I'm a fast metabolizer of caffeine. I could have an espresso at 9 p.m. and go to bed in an hour, no problem. So for me, I take my melatonin close into bedtime, right? 40 to 60 minutes before I go to bed. For my husband, Mark, he's a slow metabolizer. Like if he has coffee after 10 a.m., forget about it. He's wired, right? He's slow in metabolizing. So when I was working with him on his dosing, we eventually had to back it up where he had to take his melatonin, even 0.3 milligrams, 3 hours before bed. He had to find that sweet spot so that it would just gently rise, right? Peak between 2 to 4 a.m. and then metabolize out. And the other thing to help your melatonin naturally is you have to get full spectrum light first thing in the morning. It will shut off. I mean, that's the time like passing of the baton. Now we go to cortisol and testosterone, start your day, be active. Melatonin, soporific, yin goes down. So that's the other hack is I don't think people realize it's the darkness deficiency for sure, making sure you have proper darkness. You're wearing your blue light blocking glasses at night if you are in full spectrum light. But then also getting that bright morning light is really important for setting the stage for the next night of sleep.
You mentioned the rainbow of foods that we should be eating. Are there any particular foods that are beneficial in allowing us to endogenously create melatonin as well in addition?
Well, to go back to what JP said, there is truth in, I mean, if we don't have tryptophan, we can't get to melatonin. So somewhere in the diet, we need the tryptophan or we need the ready-made melatonin, right? But, you know, being that I am in nutrition, I get the question all the time, Deanna, can't I just have a handful of pistachios and get enough melatonin from plants? Because you see that on social media all the time, right? Have tart cherries before bedtime, help your insomnia. So I actually did some math. I just went into the studies and I looked at a lot of the plant research to find what is the range of plant melatonin in cherries. I did it for like 8 different foods, you know, walnuts, pistachios, cherries, milk. But mostly when you look in plants, you're going to find that melatonin is in the reproductive portion of plants, like seeds and nuts, which is why pistachios would seem to be high. But when I did the calculation for the amount of melatonin, which, by the way, is not standardized, so that's going to flux with seasons and everything else, right? Where is it produced? All the different varieties of pistachios. But essentially what I came to in my calculations, and I had other people check my math, is over 1,500 raw pistachios would give you 0.3 milligrams of melatonin, 0.3. And you don't want food before bedtime, right? But you do want tryptophan. You do want healthy tryptophan in the diet. There is a lot of emphasis on getting good dietary protein and increasing those levels as we get older. So that's not just for muscle mass and making sure that, we stay strong from a musculoskeletal point of view. We need proteins, different proteins and amino acids to actually help as the building block of neurotransmitters, especially serotonin and melatonin. So what would give you tryptophan, right? So this is why people think about Thanksgiving and
turkey.
Yeah,
Yep.
a lot of animal products. There are some plant products as well for people who eat more plants, but essentially looking at tryptophan is important. But it's not just getting it in the diet, it's also making sure that you're absorbing it, right? And protein digestion goes down with age. So it's like everything kind of gets stacked against us a bit, right? Like we have low melatonin, we have to enable our bodies to make it efficiently through all of those enzymes, and we have to also digest that protein efficiently. So a lot of things happen.
There's a very strong correlation between vagus nerve activation, vagus nerve functionality, and melatonin production, right? We know that tools like vagus nerve stimulation, humming, chanting, breathing, gargling, even just the vagus nerve activation exercises, when done in an appropriate manner, can help engage the vagal systems and help us get into these patterns where sleep can be initiated more readily. I'm curious as to any lifestyle practices that you have or that you talk to your patients about. You mentioned not eating before bed. Obviously, we want to leave a window 2 to 3 hours minimum of no food between kind of the last meal and bedtime. You mentioned the cyclic nature, having sunlight, full spectrum light first thing in the morning. Are there any other practices that you can engage in to help regulate vagal and melatonin-based activation?
I love your orientation into this, in terms of, how do we get there through humming? And one thing that can help to promote melatonin and even serotonin is meditation. So there have been a few studies where they look at long-term meditators. We're not talking about like weekend meditation and, then nothing. Like it has to be like a practice of consistency. But in these studies, you do find that serum levels of both melatonin and serotonin are higher in people who meditate. Also, long-term meditators have greater pineal gland integrity. They also have reduced brain age. So, it's doing something to neuronal plasticity, right? So I do think meditation, whatever that looks like for you, keeping, as we were talking about the kynurenine pathway, making sure that we stay in that state of calm, keeping our vagus nerve healthy and in place so that we're not upregulating stress response is important. I would also say, I'm going to give you a really practical tip, and that is get an app that measures lux, Lux. Lux is a unit of light. So 1 lux is equal to a candle flame about 3 feet away or 1 meter away. So if you can measure the light and know what you're getting in terms of darkness, there are all kinds of recommendations for you don't want more than 10 lux 3 hours before bedtime, right? You want to measure the lux in your sleeping room. And the way you do it is just with your phone, with the light on the phone. The app that I use is free, and it's called Light Meter Lux. So if you look it up on the App Store, it's like a little light bulb that is black with like a yellow outline. So it's Light Meter Lux. And what you do is you just open up the app and you can put it at eye level so that you can see what your eyes are looking at. Like right now, I'm in front of I purposefully work in front of a window. I have 3 windows in front of me, and that helps me. You too? Well, it helps me because you're actually taking in that light too. And we have flip-flopped our rhythm, right? Where we're dark during the day and then we're bright at night. So you want as much light as possible if you're working indoors. Going outside periodically through the day is good, but you can actually measure it. So like if you measure it, then you can kind of get a sense of like, oh, I need to tweak my light a little bit more here. I know Terry Walls, who is our colleague, I've talked with her extensively about melatonin, and we talked about a dark sleeping room. And she said, well, Deanna, for people with MS, you got to be really careful because you have instability at night. And if you have to wake up and use the restroom. So like a night light down low would be okay, right? But just keep in mind, you really want to aim for under 1 lux, under like even 0 lux in your sleeping room, wherever it is. So measure the light. This is a lifestyle practice. You can wear the blue light blocking glasses, which depending on the glasses themselves, what you're doing is you're already helping with that signal to the brain. So that's another lifestyle hack that is not so expensive. And then I like what you said about humming because it makes me think of music. Not to say that music leads to more melatonin, but we know that certain music can lead to changes in the mitochondria. There was a real neat study on that, looking at different kinds of music and generation of antioxidants, reactive oxygen species. They didn't look at melatonin specifically, but we know, it's kind of like common sense, right? If you're listening to music that's very harmonious and feels good, you're going to feel good on the inside and your cells will feel good. In the study, it was kind of funny because they also played heavy metal music to these cells and the energy production decreased. And whenever I see this study on social media, people say, but I like heavy metal. It's like, you know what? Then you're probably making energy. It just, resonance, right? You got to find your resonance there.
Yeah, individuality for sure on that particular thing. I love these practices. We're kind of leaning in towards the end of this conversation, but JP, I want to give you a chance if there's any pressing questions that you have, jump in.
No, we've just touched the surface on what melatonin does. One of the things that we talked about right before we got on, and it ties together vagus nerve stimulation, which is, I think, what you were talking about with meditation and deep breathing, and in general, controlling your autonomic nervous system in a positive, de-stressed direction. And melatonin, the importance that it has on the mitochondria is the fact that there's a direct relationship between melatonin production and the expression of that alpha-7 nicotinic acetylcholine receptor, which we've talked about on many podcasts. It's sort of the pathway of vagus nerve stimulation because acetylcholine activates it. It leads to the reduction in inflammation. But that same receptor is on the mitochondria, and the level to which it's expressed on mitochondria, on the outer membrane, is proportional to the amount of melatonin that's in the cell. So as melatonin levels rise, we're seeing a higher level of those receptors, and those receptors are listening for acetylcholine. There's certain transporters that bring the acetylcholine from outside the cell into the cell so that the mitochondria can monitor what's going on outside. Mm-hmm. So all of it's linked together. So yes, I think there's no question that activating the vagus nerve and making certain your melatonin levels are hitting it from both directions to make your mitochondria as healthy as possible.
Yeah. I love that. The mitochondria and melatonin go together. It's hand in hand. So when you have more mitochondria, think of yourself having more of the protective melatonin, right? You're just endogenously going to make that at the cellular level. I think the only thing, Navaz, that I want to leave the listeners with that might be kind of a new thing for them if they've listened to a lot of podcasts on melatonin is the brain protective effects. I do think that that's important for if we're thinking about autonomic nervous system function and balance. So I teach a lot on detoxification processes. And typically when we do that in functional medicine, we talk a lot about the liver, the gut, the lungs, the skin, the kidneys, the steady eddy big organs. But the brain needs to come into that conversation because like us talking right now, our brain doesn't have time to be detoxifying. It is working and producing lots of metabolites as a result of our thought processes. The only time that we're letting go of those toxic metabolites, whether we're building up amyloid, we're building up those hyper-tau phosphorylated proteins, whatever it is in the brain, it's got to be released at night when our brain is sleeping and under certain stages of sleep. And as it turns out, there is some preclinical work to suggest that melatonin, because again, let's just circle back to its amphiphilic nature, the fact that it can flex to being watery and fat soluble at the same time, it's very unique. It can travel and take and be kind of like that messenger molecule to carry the waste from the fatty brain into the less fatty lymphatic fluid, which is the lymphatic fluid that surrounds all those glial cells, right? So it's like we get the convection out. I want to see a nice video of this, like how the brain I see it statically in like 2D. And so the brain just kind of opens up and it's like ready to like let go of that, which is why, stimulating a lot of this upper area when we wake up, really important because the lymphatic fluid is going into the lymphatics and then we have to excrete and get that stuff out. So as it turns out, and there's still much to be uncovered here. I don't want to make this sound like it's a done deal, but Dr. Russell Reiter calls this brain washing in a good way.
And it's dialysis. It's dialysis of the brain. It's exactly what happens. You're using cerebral spinal fluid to wash through the interstitial spaces to remove the metabolic waste that's being generated. It moves from the arterial to the venous blood supply, and it's drained through the lymphatics into those lymphatic receptacles in the neck. So, yeah.
It's a beautiful process, but that's only going to happen either when we're sleeping, under certain stages of sleep, or when we're under anesthesia.
And you have to withdraw the norepinephrine. You have to withdraw norepinephrine. Acetylcholine has to rise so that the end feet of the astrocytes can actually express the aquaporin 4 and pump the lymphatic fluid across the net. And that pumping action is just yet again more of a serotonin, melatonin, cyclic, slow wave sleep motion that you need in order to clear out the gunk.
Exactly. So it just keep that in mind with melatonin because of its chemical nature, it seems to be facilitating this process. There are other things that help with lymphatic fluid. It's also about the posture, like how are you sleeping? So right lateral is the preferred side to sleep on. Even
which happens to be the exact position in which your HRV is highest at night is right lateral. Right
I didn't
side.
know that.
Yes, absolutely.
But it makes sense, right? Right lateral. My husband explains that in TCM terms because you're infiltrating the liver, which is more on the right side with blood and kind of, again, it's like brain liver access time at night. So kind of cool. So many different rabbit holes to go down because even, 1 to 3 a.m. in TCM chronotherapy is liver time. And that's like peak melatonin time, like 2 to 4 a.m. So it's kind of like brain and liver working together to get that brain clean and washed.
It's enabling that recovery process, right? The recovery, the clearing, the toxin removal. JP and I did an episode just in April that came out, episode 106 of our podcast. The entire thing was on lymphatics and that being the missing link to brain health. So for anybody who's interested in that topic, go back if you haven't listened to that episode. We dug into the science of releasing the toxins from the brain and the specific things that need to happen to enable that process to occur. So just a little plug for that past episode. I want to wrap this out with just kind of bringing it back to this idea of it looks very much like, and this is a topic that Dr. Bland, to bring it back to the beginning of our conversation, Dr. Jeffrey Bland has been championing for many, many years, the idea of immunometabolism, the immune system and how the immune system is functioning in its metabolic pathways. And the idea that when we regulate the immune system effectively, we can enable the recovery process, we can ensure brain health, we can ensure organ health at a greater level, and we can extend our health span as long as possible. And melatonin and vagus nerve and acetylcholine play a major vital role in enabling that immunometabolic process to be optimized. I think these are all kind of linked so heavily together. We all are on the same page here. We love to talk the science, but we also love to hear about kind of the spiritual link to a lot of these things. And so this has been an absolute pleasure to have you on the podcast to talk about this topic. We will for sure have you back in the future. We can dig deeper into this at some point. But this has been absolutely wonderful. I also want to congratulate you. I didn't get to on site at the IFM conference, but you are the 2025 recipient of the Linus and Ava Pauling Award. So congratulations on receiving that wonderful honor.
Thank you, Navaz. Thank you so much. This has been a great conversation. And I know we didn't touch as much on spirituality, but It's all spiritual because anytime we talk about the human body, it's like, wow, how can scientists not become just feeling like this is a huge mystery and beauty? Just when we think we have it figured out, it's like, no way. We we just continue to keep going. And, even in my undergrad, I studied not just biology, but English lit. So I was kind of like, I was really interested in that. And I remember even, Rene Descartes talking about the pineal gland as the seat of the soul.
Yes, I remember
Right.
this.
And, he was a philosopher, mathematician, kind of a Renaissance guy. But yeah, so anyway, it's all beautiful. It's all, we get to live in these bodies and spend our lifetime trying to understand them. So thanks for having this.
How can people get in touch with you? How can people learn more about not just melatonin, but all the rest of the work that you're doing?
Sure. My website, deannaminich.com, which will take you to all of my social media handles. I have started, I just remember this, a podcast, or actually it's like a YouTube channel on science and spirituality talks, where I'm interviewing people like Navaz and others on their take on science and their take on spirituality, but more from a personal take. It's not going to be like, give me the facts. It's just like, who are you as a person? And let's talk about that because that shapes everything else. And then if people want information on the plant melatonin that I talked about, that you can find on symphonynaturalhealth.com. You can read more blogs about plant melatonin. There was a study on it being 6 to 9 times greater in activity compared to synthetic melatonin. All of that stuff you can find on Symphony Natural Health. Good stuff there for sure.
I love that. This has been a wonderful conversation. I think this is pertinent to any healthcare practitioner, any health seeker. If you can work to improve your melatonin production, ensure that you have this long-standing anti-inflammatory, immune-regulating effect of melatonin throughout your life as long as possible, you're going to engage these recovery processes more readily. So thank you for this amazing conversation. For anybody who got to this point in the podcast, please share this episode with 1 or 2 people who you think could utilize this information to upgrade their health. And we'll catch you all on the next one.
Thank you.